Here in this video, we would like to derive an equation for the apparent frequency of Doppler effect when a source is in motion and observer is in the state of rest. Before going to that, let me first explain what's the definition of a Doppler effect is. What is it? Doppler effect is apparent change in the frequency due to relative motion of source and observer. Let us understand few things here. First of all, it is not the change, it's an apparent change. Frequency appears like changes due to not just motion but the relative motion of source or observer or motion of both of them. So, Doppler effect is the apparent change in the frequency due to relative motion of source and observer. Here in this case, we are talking only when the source is in motion, and we will talk about the motion of the observer at a later stage, right? So only when the source is in the state of motion. So let us imagine a source. Initially, if the source is in the state of rest, who is making a sound, observer is also in the state of rest. As the source is making sound and observer is listening to that, sound travels from source to the observer. Sound travels like a wave. So if you draw a wave, it is like this, a transverse wave. This is how the wave is going. And we can see the distance between two successive compressions or refractions or crusts or troughs is called as wavelength lambda. So if I have to write an equation for the lambda in this case, I can write lambda is simply V by N, where V is the velocity of the sound, N is the frequency of the source. This is when both observer and source are at rest. Now let us consider a case that source is not in the state of rest but is moving forward, and observer is in the state of rest itself. Now, as the source is moving forward, it pushes the wave towards the observer, so the waves comes close to each other. So you can notice clearly wavelength in this case, lambda dash, is less than lambda because source has compressed waves as it is moving towards the observer. So what is the new wavelength is in this case when source is moving towards observer. New wavelength lambda dash is original wavelength minus the wavelength reduction happened because of the velocity of the source. We know the formula as V equal to N lambda, lambda equal to V by N. And the wavelength happened because of the velocity of the source. So in the place of V, I needed to write velocity of the source minus N. So the reduced wavelength in this case is, if I take lambda, if I have to write as this is in terms of V, I can write this V also as V by N minus Vs by N. So N is common, V minus Vs. So the new wavelength in this case is V minus Vs by N. Once after knowing the wavelength, new frequency will be N dash is V by lambda dash. V by lambda dash expression we have already derived, V minus Vs by N. That implies apparent frequency is V by V minus Vs into N. This is the expression for the apparent frequency. That's the frequency as it is heard by the observer in the state of rest when the source is approaching him. Be careful, right? And if you notice little carefully further, in the numerator you have velocity of a sound, in the denominator you have velocity of the sound minus something. So denominator is less than the numerator. So total frequency n dash is greater than that of original frequency n. So apparent frequency is more than the original frequency. Be careful that the Doppler effect is valid only when only it is valid only when velocity of the source is much less than the velocity of sound. That's one thing. And there shall be a relative motion. If there is no relative change in the frequency, if there is no relative motion in the frequency, there is no Doppler effect. No relative motion, no Doppler effect. That's one case. Let's talk about another case. If source is moving away from the observer, observer is in the state of rest, but unlike the source is not approaching here, rather it is moving away. So you can say the wavelength increases now. It's not going to reduce like it is being said, as the waves are not compressed, rather waves are expanded. As the waves are expanded, new wavelength is original wavelength plus expanded wavelength because of velocity of a source. That is V by n plus Vs by n. That is V plus Vs by n. That implies new apparent frequency in this case is V by V plus Vs into n. It's very clear this denominator is more. So this frequency is less than the original frequency. So apparent frequency may increase, apparent frequency may decrease depending on how does the source is moving. So I can write a general equation as n dash is V by V plus or minus Vs into n. We have to write minus when the medium is approaching the source. When the source is approaching the observer, we have to write a plus when the source is moving away from the observer. This is the Doppler effect equation in the case of motion of only source. Next case, we will talk when the source is in the state of rest and the observer is in the state of motion. That's it. Thank you for watching.